Okay, we're going to look at first some basic definitions of trig functions, trigonometric functions, and they're going to be defined by ratios in right triangles. So we're only going to be looking at right triangles for this, and these are very important to have memorized because they come up all the time. So let's see. First of all, this angle, this thing here, hopefully you've seen it before, it's called theta. That's how you pronounce it, theta. And it's a Greek letter. It's just, usually we use it to signify angles that we don't know. It's kind of like a variable for like x would denote something. Theta denotes an angle most of the time. Actually, pretty much all the time. But so first, that's theta. And I'm going to define some trig functions. You should have seen this in geometry, but we're gonna say some stuff right now. Actually, let's name the sides of the triangle. So let's look at this triangle first. If we're focusing on this angle, then the opposite of this angle is this side. So we're going to say this is called the opposite side. And then the adjacent side, which means like next to, the adjacent side, that would be this side. And then lastly, this would be the hypotenuse. And hopefully you can do the same stuff. You can name the same things for the other triangle. So I'm going to write those down. Maybe think about it now. Depending on where your angle is, so here, this angle's in the top right corner of my triangle, the top corner of my triangle. This one is in the bottom left. So depending on where this angle is, or what angle you're focusing on, that changes what this side is. So now, instead of this being the adjacent side, it is now farthest away from the angle, so it's the opposite side. This is the adjacent side. This is still the hypotenuse. It's very, very, very important to be able to recognize which side is what, because that's how the trig functions are defined, and you won't be able to do it any other way. Or like if you don't know how to name these, then you'll be lost. So the opposite. Well, first you have to recognize what angle you're thinking of, or what angle you're focusing on. Because if you focus on this angle, then these change. So the opposite side is the one that's farthest away. It's opposite the angle in question. Yeah, the hypotenuse. Maybe that one's the easiest to find. That one's always across from the right angle, and it's the longest side in a right triangle. And then the adjacent and opposite, hopefully you can figure out after that. And those are always the legs. The opposite and adjacent, those are always the legs of the right triangle. Adjacent is the one that touches, or it's the other one that touches the angle, because the hypotenuse side also touches the angle theta, or like it makes up the angle theta. So the adjacent side is the one. I'm repeating myself a lot, but I needs to sink in. It's the adjacent side is the one that touches the angle theta in both cases. So that's first very, very important. And now we can define the trig functions based on these right triangles and the names of these sides. So here we go. I'm going to say this over and over and over again. There's a mnemonic device to remember these trig functions, but these again are definitions of trig functions. Just like we have f of x equals x squared, or like y equals 2x plus 1 for lines, these are also functions. Sine, theta, and it's defined by giving the opposite side length. So this would be opposite side length. So if I want the sine of this angle, I would get the opposite side length and divide it by the hypotenuse length. So there you go. Cosine, so this is called sine, this is called cosine, tangent, secant, cosecant, and cotangent. And these are all defined by dividing the sides of the triangle. That's just the definition for these trig functions. So this is right triangle trigonometry, just the trigonometric ratios, or trig ratios. And this is what they're defined by. A way to remember these is SOHCAHTOA. I think you've heard that before from geometry. And all that means is sine is opposite over hypotenuse. Opposite over hypotenuse. So it's the opposite side from the angle divided by the hypotenuse of the triangle. And then cosine equals adjacent, the adjacent side length divided by the hypotenuse side length, adjacent over hypotenuse. Tangent equals opposite over adjacent, opposite over adjacent. And then what about this stuff? Okay, so another thing that I'm going to point out is 1 over, cosecant, CSC, cosecant of theta, that's the same thing as 1 over sine theta. So that's a little trick. So if you remember sine, you can figure out cosecant. Now you think, like, wait a minute, shouldn't sine be paired up with secant? It's kind of backwards. It's just the way it was written and the way it was named. So cosecant is 1 over sine. What does that mean? Well, you just flip this over. Opposite over hypotenuse. Cosecant, whoops, I think I wrote down something wrong. There we go, I had them mixed up. So if sine is opposite over hypotenuse, then cosecant means I just switch these two. That's just by definition, and it's a way to remember. So 1 over sine is cosecant. So then cosecant is just, you switch those around, hypotenuse over opposite. And then cosine is adjacent over hypotenuse. And secant of theta is 1 over cosine, which means you just switch this around. So adjacent over hypotenuse, this would be hypotenuse over adjacent. And then cotangent, you just flip tangent over. So those are the trig ratios, and then we're going to see how to use them in a little bit. But these are periodic functions because of the unit circle, but we haven't talked about the unit circle yet. But once we get these trig ratios down, we'll get into the unit circle and delve into all that stuff. But these represent some things that happen over and over and over again. They represent motion for springs and stuff in physics. But so these are the foundations. You need to have these memorized. You can use the mnemonic device SOHCAHTOA to remember the first three, and then hopefully you remember these. A lot of people would think sine would be paired up with secant and cosine with cosecant because they kind of sound similar, but it's kind of backwards. Sine gets paired up with cosecant and cosine gets paired up with secant, and then tangent and cotangent go hand in hand. All right, I'm going to end this video there. It wasn't that much writing, but hopefully we can get on to some examples.